We all have seen a massive wall of if-else statements exactly like this, and when a new ticket comes in, most developers just extend it. Instead of adding another else if statement to the existing mess, what about deleting it all entirely and forcing the Java compiler to do work for us? Before we go, let's run the tests. As you can see, we are all green, so we can refactor. It's safe now. We can replace this entire block with a modern Java switch expression. It's much cleaner and readable. And if enum gets another customer type, the compiler will warn us that we forgot to handle it. IntelliJ is very helpful in such things. Here we go. But here is a catch. This works perfectly for simple logic. But what if business says, if any order is over $1,000, put additional 3% discount on top. If you put that inside the switch, it will lead to code duplication, as every case will need this change. And if you put it outside, the logic gets messy and scattered across all methods. When business rules get complex, switch statements are not enough. You need to drop it and use the strategy pattern instead. But I'll show you exactly how. The reality of software development is that business requirements are always evolving and changing. And today we will be getting rid of our beautiful switch expression, as it will completely break down because of the new business requirements that we apply to the discount calculator class. And today I will show you exactly why it will be failing and how to extend such requirements with the strategy pattern and why it should be used. Here are the business requirements that we add on top of what we have now. So previously we had a global rule: if an order is over 1,000, then we give 3 extra % on top. But as you can see, this applies to any of the switch cases, and it's not necessarily what the business wants, right? So now we will be encapsulating the way how we calculate the final amount of after discount for each of for each customer type. I will put business rules here on the bottom, so we see what we have and what we have to work on. So VIP customers should get that extra discount starting from $500. Wholesale clients only if they hit $5,000. And regular customers, they shouldn't get any extra discount at all. For regular, we don't do anything. So look, now I'll check here that if the customer is regular or customer type is wholesale or customer type, then we return the result. We can actually take it off here because for these customer types, we will be calculating the result inside of the case statements. So VIP, they get their 20% of discount. Wholesale customers, they get their 60% of discounts. If the amount wholesale customer is more than 5,000, they get additional 3% of discount. And if it is, we need to add the same check, reduce discount by 3%, and the check is on $5. So this will be calculations now. As you see, it's not that nice anymore. And why this happened? Because the switch expression, it's great for choosing a value, but it really sucks at managing complex and independent behavior. And each time the business changes the rules for one specific customer type, we will have to modify the entire calculator class, and that means that we are violating the open-closed principle. So by that all said, what we need to do is to introduce the strategy pattern. We'll be doing it by creating the simple interface and putting priority for customer types that are covered by the discount strategy. What I mean by that? We need to create, ideally, the new package with specific, where the specifics will be implemented. We put this discount strategy interface inside. This interface actually has to be public, so it's accessible outside of its package. And here we will be adding specific implementation for VIP customers, wholesale clients, and regular customers. This class needs to implement the discount strategy and needs to contain the following logic. Same for regular and for wholesale. And now we can migrate this logic inside of the strategy classes, inside each implementation. Now, as we are outside of switch statement, we simply substitute this yield by the return, and here we go. We have the wholesale covered. Now we need to do the same for VIP clients and for regulars. Now, as we have discount strategy implementations ready, next thing to do is to instantiate the strategy objects and inject them into the discount calculator. We could make these classes public and simply create it here in a way like this IP discount strategy, right? And then apply it. Yeah, if we make this class public, becomes accessible here. We can import it and apply it kind of like that. Or, okay, yeah, I see. So it's more like that. For example, yeah, this is the way to go. Actually, we can do like that first. We can do like that first, and then we can improve. So as you see, it's still not ideal because, first of all, if we need to add additional strategy for employee or for student or for regular or for new customer, we will need to be creating new strategy in this place, and it should not be the case because this place is just calculator. So now it has to encapsulate the application of the discount strategies in current place, but not the definition of this strategy. That's why Java has such beautiful things as access modifiers, by which you can control, and you should control, the accessibility of the cross package. Meaning that for this specific case, what we should do is to create factory, which will be responsible for one single use case, for one single piece of logic. It will be creating and it will be holding the different strategies, different discount strategies. So if a new discount strategy appears, we will need to modify only this factory to add the new discount strategy here and to implement the discount strategy itself. So let's do it. It should return the list of discount strategy, as it's the only type that is available outside of the discount specific package. Get strat, and it should return the list of whole strategies that it has, which is regular strategy, AP strategy, and wholesale strategy. So we have this ready, and now we simply create strategies here. So this field contains the strategies and the factory helps to generate them. But now, how do we know which strategy should be applied to which scenario, to which case? As these enums, they are not really, as this enum now cannot be matched to the discount strategy itself. One of the ways to do it is to create the method in the discount strategy interface, which gets the customer type as an argument and is able to understand what is this customer, who is this customer. Yes, now we have to extract this enum to upper level. Yeah, this is what we need to do, as it needs to be accessible now across the whole application. So now, as you can see, it is accessible, and the only thing we need to do now is to implement the method and understand that for the wholesale customer, the strategy is applicable when this method returns true. Same happens for VIP customer. Now it's basically the same check for the VIP and for the regular. This is not the only way to do it, but it's one of the ways which is pretty much alright in our current case. And now what we are going to do is go through these strategies and find that if what we need to do is to go through these strategies, to iterate through them and find out if any strategy applies to the customer type which is about to get the discount. The only thing to consider here is that now we will need to handle the switch in a bit different way, because actually, yes, case by default should throw exception, otherwise through regular or VIP or the wholesale. So now we need to find the strategy which we have to apply to the customer. We'll be doing it by strategy applies. So we check by customer type if the strategy is applicable and find if it is present, we return the amount from it. And this now will be covering the cases for the new business rules. To verify it, we should check now that regular will get no discount, that wholesale will be getting discount, but only, 60%, and if it is 10,000, it should be not 6, but 5,700. And for VIP, they get their 80 for 100, but if it's over 500, so let's say 1,000, they should get 770. Let's run it. Well, this is actually not our fault, but fault of Java, and this is the reason why double is not really used and should not be used for some really precise calculations. And it's not used in banking or in any financial institutions, any financial applications, as you can see, the fraction, small fraction, but still a fraction of amount disappeared, and in some cases it's not acceptable. Actually, if it is interesting for you, I can cover the actual cause and the Java type which should be used instead in the next video. But nevertheless, returning back to our discounts, as you can see now, if you take a look to the calculator class, we partially replaced the switch statement with combination, these several lines of code, and we fetch the strategy from the strategy factory and just execute it. So this code in current state, it's more prepared for the business. If it comes tomorrow and says that the new discount is on the way, this time for students, then we just extract this case from the current switch, add here the new student strategy, implement it, and we are ready to go. Now it is almost full single responsibility and open closed principle, and this is basically how you scale the production architecture from a simple pet project to higher level kind of enterprise system. So drop your thoughts on strategy versus switch in the comments, and don't forget to subscribe, and see you in the next video.